Welcome everyone, and thank you for attending today's webinar, Surface to Seafloor Unmanned Systems from Teledyne Marine. My name is Melissa Rossi, and I'm the Director of Marketing and Customer Service for Teledyne Marine Vehicles. I have a few general housekeeping things that I'd like to tell you first, and then I'll introduce today's speaker, and we'll get started. So today's session, everyone is in mute mode due to the large attendance. If you have a question about anything you see or hear during the presentation, please submit your question to us. There should be a question area in the control panel that you can submit from. It either has a question mark or it says question on it. And please do that when you think about the question so that you won't forget what it is. At the end of the presentation today, we'll try to answer everyone's questions as they've been submitted. If for any reason we don't get to your question, there'll be a list of contacts on the final slide so that you can reach out directly and get your questions answered. We also have 5 handouts today that are posted and available on your control panel. You're welcome to download them at any time during the presentation. About 24 hours after the webinar is over, you should receive an email with a link to the recording from today's session. Please be sure to check our link landing page, which can be accessed from our website homepage and from many of our social media posts and email marketing efforts. We've got some great topics coming up, including tomorrow's Power Half Hour with Paul Devine that's titled ADCP Data Dive into the Mississippi. And for the vehicles team, Hugh Farger from our Apex team and 2 of our Apex engineers will be presenting measuring storm-generated ocean currents using the Earth's magnetic field. That'll be on July 8th, which focuses on the work that our customers are doing with the Apex EM profiling float. So we have some really great content coming up as we're rolling into the summer months, and we hope you'll join us for some of the other webinars we have scheduled. So without further ado, let's get this webinar rolling. Today's speaker is Arnar Steingrimsson. Arnar is the Senior Director for Business Development, Marine Vehicles for Teledyne Marine. In his capacity, Arnar works globally across the vehicle's product lines in a BD sales role, in addition to having responsibilities for our vehicle's product line management team. Arnar's been working with Unmanned Systems since 2003 when he joined Teledyne GAVIA's predecessor, Huffman, and has played an active role in introducing unmanned vehicles to commercial, military, and scientific customers around the world. So without further ado, here's Arnar. Take it away.
Yeah, thank you, Melissa, and thank you all for being with us. No matter where you may be, we have attendees I saw from all over the world, so good morning, good afternoon, good evening. Thank you for taking the time out of your busy schedule to be with us for this webinar. I realize that we are certainly living through some challenging times here today, so I hope first and foremost that we find you and your loved ones healthy and safe. And I do hope to be able to see many of you in person at industry events towards the end of this year, or perhaps even meetings if we ever start doing those again, when things return back to normal. So, and how do okay, there we go. This presentation, I'm going to focus on the Teledyne Marine Vehicles overview. I'll provide a little overview of Teledyne Marine, what we do, a little bit about the Marine Vehicles Group. We'll touch on some market trends, and then look at the products that we have within the portfolio of the vehicles group at Teledyne, and then we'll look at a case study. Now the intention is for this to be the first of 2 kind of webinars on the broad portfolio of vehicles, and the second one I'll line up will be really focused on customer use cases. So if any of you are online, I know I saw a number of our customers that are registered for this event. If you'd like to join me for the second of these webinars, please drop me a line, or you can put something in the chat window if you're interested in presenting some of the things that you're doing with our vehicles for 5 or 10 minutes in an upcoming presentation. So a little bit about Teledyne Marine. So Teledyne Technologies is the parent company of Teledyne Marine, headquartered out of Thousand Oaks, California, about a $3 billion publicly traded U.S. conglomerate. We have over 10,000 employees, I think over 100 different business units. Teledyne Technologies is split into 4 operating segments, instrumentations being one of those, and Teledyne Marine is roughly 1/2 of that instrumentations segment. Now we have 23 different what we call product brands, really all grown by acquisition. When Teledyne decided to get into the marine space starting in 2005 with the first acquisition of Teledyne RD Instruments out in California. Soon followed after there by Benthos and Cape Cod, and eventually ended up being 23 different companies that they acquired. About 5 years ago, we took a new direction kind of with Teledyne Marine. There was Mike Reed, who's the president of Teledyne Marine, kind of consolidated the operation, so consolidated the management team, consolidated the engineering resources, the sales teams, and the idea was that together these companies could certainly provide better value to our customers and better solutions all working together than the 23 individual companies could prior to that. And you see some of the locations where we are, technology clusters in California, Florida, Houston, Northeast US, where I work out of, and then facilities in Europe, South America, and Asia. Now, in this talk, we'll be focusing on the vehicles vertical, which is one of the 5 technology verticals that Teledyne Marine splits up and goes to market. And while I'll primarily be focusing on the vehicles vertical, it's worth mentioning that we have a lot of other capability across the board. And Teledyne can come at the problems or solutions that you're looking for in a number of different ways. It may not involve robotics, but we have a lot of other capability, market-leading sensor manufacturers, things like sonars from Rezon or multi-beams, acoustic communication, positioning from Benthos, Doppler velocity logs, and current profilers from RD Instruments, all the way down to the building blocks of most things with the interconnect piece. So we can come at again issues and problems a number of different ways. What we do in the vehicles vertical is that we're really in the data acquisition business. We're data acquisition from the surface of 6,000 meter depths. The vehicles or the platforms are really secondary. It's all about the sensors and the data and putting those sensors at a particular location at a particular period of time. And to do that, we have a whole suite of unmanned systems that we'll touch on in this talk, and they're all optimized for certain operational profiles, whether that's bottom scanning with multi-beams or sonars, or water column oceanographic type measurements, or light intervention or inspection type tasks with ROVs. We have a number of different vehicle platforms that can be utilized to meet user requirements. And we, Teledyne Marine Vehicles Group and Teledyne Marine and Teledyne Technologies for that matter, I think we're pretty evenly split in our market focus with science, defense, and then the oil and gas commercial applications of these products. And the brands that we have within the vehicles group, and we'll touch on these in detail, Teledyne Benthos, which is located here in Cape Cod, Massachusetts, where I work out of. We have, at Benthos, we have a wide variety of products, largely on the instrumentation side, the communication, positioning, releases, but we also have vehicle platforms with the deep-towed systems. We have up in Iceland the propeller-driven AUV group, so the GAVIA group doing GAVIA and Craptor AUVs that we'll look at. And also here in Falmouth, Web Research, which does persistent monitoring, autonomous underwater vehicles, gliders, apex floats, and also sound sources. And then wrapping it up in California, we have the Ocean Science Group doing small unmanned surface vehicles and the remotely operated vehicles of Teledyne ZBoat. And if you're in the market to purchase or to get into unmanned systems, there are a number of things to keep in mind. There's of course there's lots of research institutions around the world that are engaged in developing systems, and there's a big difference there with developing systems one-offs and consistently being able to deliver repeatable kinds of results with these vehicles. And when you look at who's on the of actual manufacturers of these systems, there's really only a handful of companies in the world that have sold vehicles in any quantity. And interestingly enough, most of those are here in Massachusetts for some reason. But a couple of things to keep in mind. So there's other manufacturers, but we differentiate at Teledyne Marine Vehicles Group roughly along these lines. One thing is that we're really using commercial technology, meaning that all these vehicle platforms that we'll touch on were developed for non-military or scientific applications. And that typically means that most of the vehicles that we make are non-ITAR. And ITAR, for the non-US folks out there, if you're not familiar with that, is an US export control, which can be quite stringent. So typically readily exportable systems. And if you're using commercial technology or COTS, this tends to be much more cost effective than specific defense articles or bespoke solutions. Certainly have mature technology. We've across the vehicles portfolio, for instance, we have 1,500 ROVs delivered at ZBoat. We have well over 800 gliders delivered from Web Research, over 9,000 floats. Proven performance. So these vehicles have been used in naval programs of records, used for commercial and scientific programs around the world. And another part of that, as a result of having those kinds of numbers in operation, is that we've really developed world-class training and support for all those vehicles. So we have training support programs that we've developed, combined with the global reach of Teledyne technologies. And we're a secure supply, pretty low risk proposition to go with Teledyne, publicly traded company. We're not going anywhere in the near future. A couple of things to touch on market trends, right? And as I thought about this, I thought about my close to 20 years in this business now, and kind of the difference that we've seen from the beginning, where you'd put robots in the water and you weren't quite sure if they were actually coming back, and that's really, those days are long gone. It's mature technology. If you look at any commercial operation, any kind of military operation, naval mine countermeasures operations, there's going to be unmanned systems that are going to be used. And instead, what we really have is the push to increase the capability that's ongoing, adding autonomy, adding smarts and capability to those vehicles, adding the endurance, higher quality payloads, and then these systems being utilized as systems of systems. And we have a number of examples of that, both with on the military side, big European programs being won by one of the French companies there. We have folks that are utilizing fleets of AUVs and USVs together. So a lot of work being done in that area. And then you have some specific drivers coming from a lot of oil and gas, deeper, also science, and then things like resident systems for oil and gas and scientific and military applications. Another interesting dynamic is that it's really the defense applications of these systems that's driving development. And when you look at market reports, for instance, I pulled the Douglas Westward World AUV Market Forecast, the latest Douglas Westward report, and they look at UUVs, so AUVs, gliders combined, and they predict that 70% of all of that demand will be going for defense applications, 3% going to the commercial sector, and the remainder being for scientific applications. And that goes without saying, thus, that a majority of the R&D dollars and technology being developed will be developed for defense applications. There's a number of large U.S. Navy programs, procurements that are underway now, recompete for LBSG, the Mark 18 Mod 1 recompete, the MUUV, so large programs that are going to really push the boundaries and push the technology considerably. But what I think is worth mentioning is the opportunity for commercial and scientific users to kind of leverage a lot of that know-how and defense expenditures, right? So you look at the things that are playing in the graphics on the right-hand side of this slide here. So that's a small USV, small low-cost USV, unmanned surface vehicle combined with a remotely operated vehicle. A lot of that work, for instance, has been driven by mine countermeasures requirements. But in this case, this is a low-cost version of that that was delivered for pipeline inspection. And the image on the bottom right is from a blue view of one of the Teledyne sensors, high-frequency multi-beam that was integrated into the AUV primarily for doing gap fill of side-scan sonar to increase the area coverage rate for mine countermeasures applications, and also for doing mine identification because of the very high frequency and associated high resolution. But in this case, you can see that those tools are also great, again, for a commercial application, and that example is a pipeline that's been surveyed by that tool. So some considerable opportunities there. Worth mentioning a few initiatives that we have going on here across the product lines within the Teledyne Marine Vehicles Group, and across Teledyne Marine is a focus on improving service and support, so improving the customer experience through that. We have a vice president that's been hired at a Teledyne Marine level to look at improving, how do we improve service and support? How can we better leverage those 23 individual brands and the 15 locations that we have to serve our customers? There's also a focus on core products. So we've had some obsolescence issues where we've had end of life with certain components, and we've actually reduced some product lines. But what that's allowing us to do is to better focus on the core products and better service those product lines and the customers that are using those. Big push in enhancing the capability of the various autonomous systems, whether you adding autonomy through things like onboard processing that we're working with folks like Teledyne Keras or Keras on board, for instance, that we use across the vehicle's platforms. Things like automatic target recognition and autonomous pipeline tracking. Certainly a focus on usability and interoperability. So multi-system operations, we've demonstrated that at events like the AMTEX, the U.S. Navy's Advanced Naval Technology Exercise, where we had a combined unmanned system, USV, AUV, ROV, and UAV, all working for mine countermeasures applications. And to do that, also one of the key things is the standardization of protocols, right? So things like the JANUS acoustic communication, which Teledyne Benthos has been involved in, where if you're running various types of unmanned systems together, you need some kind of a means for those systems to communicate, and also a combined command and control. Then certainly things like higher performance sensors. You see an image on the bottom right is a synthetic aperture sonar from one of our AUVs, doing things like adding capability with the electromagnetic EM Apex for current profiling, adding a lot of capability to these platforms. And then we also realized that there's no one single vehicle that can do everything, and there's really no single manufacturer that can do everything. So we really we want to provide solutions to our customers, and to do that, we're actively involved in a number of partnership projects. I'll touch a little bit on the Trimble edition, ZBoat, in the talk, but we're doing things with folks like Charles River Analytics for autonomy and ATR. We work with Seabite and Green Sea, for instance, across the brands for autonomy options. Just real quick, this is an old slide that I use, but you know, this kind of goes back to the point that the vehicles themselves, I guess, are a bit secondary. It's the data, but you know, why are they using them? And this is a pretty graphic example of that. And what you see here in this image is an image of oil or a natural gas platform in Southeast Asia. You see the three structures of that platform in the photograph, and then you have AUV data on the left-hand side, and then you have conventional survey data on the right-hand side. Conventional survey data being done from a ship operating outside the exclusion zone. AUV very close to the bottom using higher resolution sensors, and what you actually see is that you're missing details that are, which is the cratering caused by natural gas. So you see on the image on the left, you see a number of craters close to the platform, and you're missing many of those on the image on the right. So it's a potential hazard to that platform. So exceptional data quality is really what it's all about. Quantity, I think the first bullet is referring to gliders, and then lower cost. And we'll talk a little bit about that, show an example of that. That lower cost is really when you get rid of a large, expensive vessel, right? So let the autonomous systems work from either vessels of opportunity, manage the missions remotely, or from some platform that's more in tune with your requirements, rather than, say, a large supply vessel or a large survey launch. And these unmanned systems, as we'll see, that they can operate in areas that are challenging for other assets in deep areas and very shallow waters, hazardous areas. So risk reduction, you know, if you lose one of these robots, you're dealing with the insurance company, but it's not a catastrophe. And then the concept of the force multiplier, right? So adding capability to the assets that you have. Shift gears a little bit and look at some of the individual products that we have within Teledyne Marine Vehicles. We don't have quite time to really get in depth into each product, or provide hopefully a little bit of overview. And what we hope to have is follow-on conversations with you if you're interested in learning more. Melissa also has some flyers that are available through this software that you can pull down and take a look at, and we'll also send out a follow-on email with a little more information. Looking at the gliders, so the gliders, the Slocum Glider, or the glider technology was started by Doug Webb. So Doug Webb came out of Woods Hole Oceanographic here in Cape Cod, started Web Research, and is the originator of glider technology. We're by far the market leader in this area. We have over 850 G1, 2, and 3 Slocum gliders delivered. We have over 40 payloads that we've integrated through the years. The gliders are either standard as a 1,000 meter rated system, and then you have buoyancy engines that are optimized for certain depth profiles, but 1,000 meter depth rating. Worth mentioning that we do have a 4,000 meter rated system under development. We're targeting deliveries of those by the end of the year. And when you look at gliders versus, say, propeller-driven AUVs or other assets, you're measuring endurance there in weeks, months, and even over a year. And so very energy efficient, utilize lithium, either primaries or alkalines, or lithium secondaries is one of the things that we brought out with the G3 is the rechargeable batteries. Another option that sets us apart from other gliders that are commercially available is this hybrid option. So this thruster, which can be used to augment the vehicle in particular environmental conditions or in scenarios where you're operating, say, outside the optimum energy usage of your buoyancy engine. If we take a look at what glider operations look like, so these are basically the vehicles use a buoyancy engine to make themselves positively or negatively buoyant. They then get their locomotion through the water from the wings that you see. So the vehicle's always traveling in that kind of sawtooth or yaw pattern. What you see here is an example of a glider being used for storm survey. So a glider's been launched in an incoming storm. It's going out gathering oceanographic data, in this case, doing current profiling, so using ADCPs. It would also carry a number of other types of sensors. And one thing that's different about, again, with this versus other AUVs is that both the glider and the floats are managed remotely in a sense. They come up to the surface at programmed intervals, and then they'll send back all their data, both the data from the sensors, but then also the mission data. And the sensors is what it's all about. With the gliders, they tend to be either optical, acoustic, or chemical, also getting into a lot of interesting applications now with passive acoustics and mammal monitoring and a number of things that we're doing in those areas. But you see a wide variety of different sensors that we can put on the vehicles. You see a couple of examples here. It looks like a Rockland micro rider, ADCP, acoustic modem, and I think a Suna down there on the bottom. So a lot of options depending on what you're trying to do. This slide here is something that the U.S. Navy's Naval Oceanographic Office published, and it talks about why they're using gliders. And when I mentioned why are people using AUVs, one of the things about the cost, right? And it's really a striking statistic when you look at when you're using a glider compared to a surface ship that each profile, so going down and up and gathering that oceanographic data, costs about $100. When you compare that to an oceanographic vessel with a crew, you're looking at $10,000 really for the same data. And you've spent more in 3 days than you have on the procurement of the glider itself. So a pretty stark example of the kinds of cost savings and capabilities that can be realized by using gliders. Touch on floats as well. So at Teledyne Web Research, again, we're kind of one of our big focus is these persistent monitoring, long duration environmental water column devices. The float uses much same kind of concept of as the glider, uses a buoyancy engine, so it's either negatively, positively, or neutrally buoyant. But it's not using the wings for locomotion. It's drifting with the current. So these are drifters and gathering oceanographic data in the water column. And so these are probably, if you look at cost, for instance, probably about 10% of the cost of a glider, but deliver a lot of capability. So the Argo programs, which is a global kind of open program to deliver oceanographic data on the salinity and temperature and other oceanographic data in the top 2,000 meters of oceans around the world. And that's a public database. So we're one of the big contributors to that. Number of different sensors available. Again, it's worth mentioning the EM, where we're actually able to do current profiling with that system, and we support a number of those kind of core Argo program goals, and then you see some of the other Argo, different Argo offshoots that we're working in. Certainly worth mentioning the deep apex, so the standard apex floats are 2,000 meters rated, tend to be aluminum hulls or carbon fiber. But the deep apex, 6,000 meters, first deep rated float, or 6,000 meter rated float commercially available. We've delivered over 50 of these, and these now utilize a buoyancy engine again, but are utilizing glass that's protected by that hard hat. And you see some of the sensors that we can put on this float, and this was really developed to meet the requirements of the deep Argo program. And again, like the glider, they use telemetry. It'll come up to the surface. It'll send the data that it's gathered on the profile over the satellite connection. And the floats typically are not recovered, but that's changing a bit when you look at some of the more expensive versions of that, like the deep. Shifting gears a little bit to look at the small unmanned surface vehicles that we have at Ocean Science, so Q and ZBoats. We're one of the market leaders there in remotely operated, tethered, and autonomous small, low logistics, expeditionary, whatever you want to call it, vehicles. We have a number of different models that we have available on this side. And these systems are, like most of our systems, modular in the sense that you can put a number of different sensors. We've integrated a number of different capabilities into these, largely doing kind of bottom survey, so multi-beam, single beam, side scan, things like current profiling, then water quality monitoring, and even top side LiDAR infrastructure inspection. And really why people utilize these is it's solving the problem of remote survey operations, right? So if you have a really remote survey, it can be very difficult and costly to mobilize other assets in there. You have to mobilize a survey launch. For instance, it's not so straightforward to put that in the back of a pickup truck and go to a remote location and do survey. Expeditionary, in a sense that, very mobile, rapid data acquisition, and it's lower cost survey than other means, and certainly a tool to use in areas that you don't want, that are either hazardous or you don't want to have personnel involved in. For the ZBoats, we have two different versions. We have a 1250 and an 1800, and the 1250 and 1800 is the lengths in millimeters, also to give you a feel for the actual size. The 1250 is a one-man portable device, typically using single beam echo sounders, ADCPs, ADCP software. While the larger 1800, you're getting into things again like the true multi-beams, and you see a list of some of those payloads there on the right-hand side. Worth noting, we certainly have our ODM single beams and multi-beams, but also R2 sonic. So that's one point to mention, is that we really do try to provide the best solutions for our requirements, and we put other people's sensors on these vehicles just like other competitors buy our sensors from us and put them on our vehicles. Worth mentioning the kind of partnership that we have with Trimble. So a very interesting application here is where we've combined forces with Trimble and their sales network, the SciTech sales network, to do a specialized version of the ZBoat 18, the ZBoat 1800-T from Trimble. And this features a ODM dual frequency single beam coupled with a Trimble BX992 GNSS receiver and the Trimble Marine construction software, which is really a derivative of the PDS software that we have within Teledyne that's optimized for marine construction activities through our work with Trimble and dredging as well. So this is something that we're very excited about and we're promoting. And here you see an example of that kind of remote ability of these vehicles. You have a couple of pictures here on the Z-boat in the back of a pickup truck going out on the ice where, you know, it's difficult to get a launch out there, and if you can stay on dry land while the vehicle is doing its survey, all the better. And then the kind of infrastructure inspection activities that we can do with these small Z-boats is very beneficial to our users. Looking at the kind of classical AUVs, so propeller-driven AUVs, I'll touch on a couple of those. And this is the newest member to the GAVIA family in Iceland, so the Craptor AUV. And this is definitely not a low logistics expeditionary class system like you saw in the Z-boat. So these are large AUVs, they're 3,000 or 6,000 meters rated. And you see the dimensions there. So 5.5 meters, 1,100 kilos, 630 millimeter diameter. And that's really driven by, if you have to get down to 3,000 or 6,000 meters, you want to get down there and you want to stay for 24, 36 hours, whatever it is. And you need to use sensors that are somewhat power hungry. So it's really just all a function of that. You need a lot of energy for these larger vehicles. This is an interesting project because we delivered this to a current GAVIA user who wanted that additional capability to go to 6,000 meters. And we built it on the proven GAVIA software architecture and user interface. And it was we delivered this on time within 18 months of contract as a joint Teledyne Marine effort with the payloads and the DVLs, navigation, a lot of things coming together to make that work. And you see here just a couple of images from sea trials with operations with the Icelandic Coast Guard. Object of interest on the side scan, which turns out to, when we take a closer look at it, matches the dimensions of a World War II B-24 Liberator. Same target data here from the Rezon T50 multi-beam. Now, another way of doing deep tow surveys, or deep surveys rather, is to use towed vehicles. And we had a lot of interest both on the AUV and the deep tow side, really around the MH370, so the Malaysian Airlines aircraft that went down a few years back. When that unfortunate incident happened, a lot of governments, certainly in Asia and around the world, realized they just really don't have capabilities to do survey at 6,000 meters. It turns out it's really tough. It's really hard to get down there and to survey such large areas. So that led to a lot of interest on the deep tows, deep AUVs. And the deep towed system is much like the AUV. It carries the same types of sensors. You're going to have your multi-beams, you're going to have your side scans, your synthetic aperture, whatever it is, sub-bottoms, magnetometers. And it's just another way of gathering that data. And there's going to be pros and cons a deep towed system doesn't have to come up and swap batteries every 24 hours. But at the same time, the deep tow is not going to operate 10 meters altitude off the ocean floor and gather some of that high resolution data. So there's really trade-offs, and again, it comes back to that point that at Teledyne Marine, we can come at your problem a number of different ways, and what the right solution is really kind of depends on what your operational scenarios are, and we'd love to talk to you about those. See some of the applications there. Any kind of deep search, search and recovery, certainly a huge application. Mining, marine, the minerals is coming online. A lot of requirements coming out of both India and Australia on that front. Shifting back to the AUV, so we also have the GAVIA AUV up in Iceland, and it's a small, man-portable, low logistics, expeditionary AUV, and the difference between the GAVIA and other autonomous underwater vehicles of that class is first the depth rating. So we do 500 or 1,000 meter depth rating, and then the modularity that you see on the screen there. So you see in the field, a user can go and assemble these modules depending on what your requirement is, put in a sub-bottom profile or put in a multi-beam depending on the mission. And what it also means is that you can add additional batteries, right? So you can either swap batteries once they're depleted to keep the vehicle going, or you can add more than one battery for longer duration type missions. And I'll come back to, since it's only fitting because it is the 17th of June, Icelandic Independence Day, I will come back and the case study that we'll look at is from GAVIA. But first, let me touch on the ZBoat ROVs that are out of California. So we're one of the Teledyne is one of the market leaders in the man-portable kind of inspection class ROVs. We do these in a few different depth ratings down to 950 meters. A number of different models that are available. Wide variety of different payloads. I'll touch on some of those payloads, and then we have some pretty interesting specialty versions for hull inspection and more. And this is the product line that has been affected, as I mentioned at the beginning of the talk, kind of the focus on the core products, and now we're ZBoat has discontinued the LBV line, and we're only focusing on the larger VLBV, or the Vectored Little Benthic vehicle line. Looking at some of the payloads that we have for those systems, you have your typical kind of ROV payloads, your cameras, your lights, but we also have some pretty interesting ones. So hydrocarbon leak detection, the ultrasonic thickness gauge and CP for pipeline inspection applications, magnetometers, cable pipe trackers. And you see even the image on the bottom left-hand side is a ZBoat system that's equipped with a mine neutralization device, the Viper, that we're selling for certain military applications. And when you look at some of the specialty versions, this is worth mentioning here, the crawler attachment. So you can take any VLBV, can be equipped with this crawler attachment, which just bolts onto the bottom of the ROV, and it creates a vortex. So it holds the ROV to a surface, which in this case looks to be a pier of some sort. Of course, this also has applications for hull inspection, right? So you can attach the ROV to the side of a ship hull, and what it allows the operator to do is to focus more on the input from the sensors and the task at hand, rather than just flying the vehicle. So that's something that we're certainly putting a lot of focus on, is the usability of these systems. That's one example of that. We also have some great examples, although we don't have time to get into them, of the kind of the autonomy packages that we have for the ROV, the Green Sea and the ZBoat systems as well. So just my last 5 minutes here, let me touch on a recent mission that was done up in Iceland. Like I said, my goal is to have a second one of these that I hopefully that you can join us for, where we will look at nothing but customer use cases. And this one, just wanted to put this out there, might give you a little food for thought. And like I said, since it is Independence Day, we'll take a look at this. So a recent survey that was done in Seafloor in Iceland. So this is the where you see on the map where the red dot is, and if you're familiar at all with Icelandic geography, Reykjavik, which is the capital, is in the southwest, where pretty much everyone lives. So a survey done in a remote location in the northeast of Iceland. And what this focused on was looking at a British oil tanker, the SS El Grillo, which was sunk by a German air attack during the Second World War in February 1944. This oil tanker, as one would expect, is fully loaded, carrying a cargo of oil. But in addition to that oil, it was an armed merchantman. So it's carrying numerous anti-aircraft guns, as well as depth charges. So when the vessel went down, there's certainly hazards, environmental hazards from the oil cargo, but also potential hazards from unexploded ordnance, or UXO. So you have anti-aircraft shells, depth charges, other hazards in the area that really need to be charted. The primary driver, again, the environmental issue, is that they've tried to pump some oil out of this wreck, but they haven't been able to do that due to the complexity of the operation fully. And what complicates matters is for the Icelandic Coast Guard to do this, they would have to rely on their survey launches. So one, it's an expensive proposition to sail all around the country and to divert it from other tasks, but it's carrying multi-beams. As a matter of fact, I think there are multi-beams, but those multi-beams are optimized to do depth measurements over a large area, not optimized for high resolution surveys of objects of interest like ships or aircraft or whatever. To do that, you typically need side scan or higher frequency multi-beams for sure. And so what we were able to do is deploy throw the AUVs on the back of the pickup truck, drive to the northeast of Iceland, and to assist the Coast Guard with putting a number of different sensors on that target. So you saw the modularity shown in that video, and because of that, we're able to drop in a few different payloads to see the varying or provide varying data sets on the target, each having their pros and cons. But we put a EdgeTech 2205 side scan. We put a Klein UUV 3500, which also has the bathymetric option. We used the Teledyne Blueview 2250 multi-beam. Also had a camera, which was completely useless because of the sediment in the water column. And over a course of a couple of days in early May, we ran 9 missions, traveled or gathered over 75 kilometers of survey lines over the course of about 12 hours. And this is the kind of data that you can get an example of, and it goes back to that first point. Why are people using any of these unmanned systems? It's because they can deliver results. And in this case, you see the side scan image of the El Grillo. You see a lot of detail in this. You see both the condition of the wreck, and then you also see a lot of the hazards, right? So if you look at other ways that you might do this survey. You might do this survey with a towfish side scan sonar. Well, you don't want to get too close to it because there's cables, there's all kinds of protrusions, areas that you really don't want to get too close to. Really have to be careful with ROVs as well. You can get them caught in all this debris. So the AUV in this case is a great tool, especially when you're in a fjord that typically has a narrow fjord with high walls, which make it also difficult if you're using towed assets to turn around, for instance. And then you also see, I think the only usable image that I saw was a cod there. So that's in these kinds of surveys, optical data really is going to vary depending on your ocean conditions. You can get fantastic data, or you can not get anything. And you see here an example that RAC wide area survey, so side scan sonar mosaic. So we've charted, meaning a number of different kind of data sets or files put together to make one image. Center of it being the El Grillo there, and what we've done also is we've draped over the bathymetry, so the depth measurements of the multi-beam to give the user additional data points. And you see the data on the bottom right there, the point cloud over that target, so that another bit of information for the end client to use for their purposes. So that pretty much covers the presentation that we have for today. I will open it up for questions, but I do want to point out, Melissa, is my presentation still showing?
It is, just the question slide. There we go. There's your contact.
Yeah, I did want to point out, I'm always happy to help, and you have my contact details there on the bottom of the slide. But I really I want to mention my colleagues on the sales team, and they're the regional sales team. So we have Jamie Jamie Carrig in the Americas. You have Valentin Hans that's doing Europe, Middle East, Africa. John Ang in Asia Pacific. Ahmad Javed, who just recently joined us, happy to say, covering the Middle East. And then we have Mario de la Cruz, who's covering Latin America. So these are all great points of contact should you have questions in now or in the future. And I think we'll include all their contact details on the email that goes out.
Okay. So we only have one question other than the question. We had a couple people ask us if the presentation was going to be available after the webinar was over, and you'll receive a link to the recorded webinar tomorrow, about 24 hours after this concludes, with a link to the full video of the webinar. So you'll get that tomorrow. We did have a question on, do we have any plans for launching swarm AUVs?
So we've certainly looked at swarming. Swarming to me implies that you have very low cost AUVs that you can utilize for swarming, and within our portfolio we don't have very low end AUVs that could be utilized in a swarming application. But we're certainly looking at it. So we've had a number of discussions with third parties that provide the kind of swarming, some of the capability to deliver swarming. We also have a lot of that in-house, so the communication piece is one thing. So at Teledyne Benthos, with the acoustic communication capability that we have some of the building blocks. So to answer the question, yes, we're looking at it, but we don't have any immediate kind of customer requirements that are demanding that capability.
Okay. I don't have any other questions in the queue. If someone in the audience is interested in asking Arnar a question live, you're welcome. There's an icon to raise your hand, and I can unmute you if you'd like to ask that question. We have maybe about 5 minutes left that we can ask any live questions if you have any. Okay, I don't see any, so I'm going to say we're all set then.
I think we covered everything so well, is what I suspected.
Absolutely. There's no questions left to ask.
Yeah. If there's anything, we like I said at the beginning, we'd love to have any discussions with you if you do have any requirements for unmanned systems. And I know many of you that are attending from the attendee list, and I do hope to get a chance to see each and every one of you later this year. Be safe.
Yeah, and also just finally, again, you have the list of our sales staff there. You're welcome to reach out to any of them, including Arnar, if you have any questions. Also, if you have any suggestions for future webinars that you'd like to see us present, please send one of us a comment about today's webinar and your suggestions for what you'd like to see us present in the future. We'd love to do it for you. Thanks, everyone. I guess that's a wrap. Oh, wait, we have one last question. I'm sorry. Sorry. Now we've got a couple. Let's see. Thanks. Can you repeat the number of sensors of a glider, please? I think that was the list of sensors we offer on the glider.
Yeah, I think, and I'm not sure if Claire is on here as well, if she needs to come in, but we do have, I think we've integrated over 40 different types of sensors on the gliders. And if you have something, we can provide you with a list of what we have integrated. But then there's also some options to do customs integration. So I would, I think the best approach is to talk to us about what you're trying to do. We can tell you the solutions that we currently have, and then we can talk about what we might be able to do if those don't meet your requirements.
Great. All right, everybody. Thanks. We hope to see you at another Teledyne Marine Link webinar soon. Thanks for joining us today. Have a safe day. Bye.